All right, this is going to be the install video for the Ground Zero Add-a-Stage tubes gain stage PCB board. Okay, I'm going to go over a lot in this video. We're going to cover a lot of ground. We're going to be using this 1979 Marshall JMP 2203. It's a bone stock amp. There's no mods at all to it, so it's perfect for this demo. So we're gonna it's got filter caps changed. It's got new power tubes. Just maintenance type stuff, but nothing significant to change the core tone of the amp. So I'm going to cover everything from beginning to end. How to install the board in the amp, how to wire it up, how to install the DC heaters. We're going to cover two different types of DC heater units you can use, which one's going to be best for you and your situation. I'm going to do some demo clips. So I'm going to install this Add-a-Stage in two different positions in the amp. I'm going to install it up front, in front of the first preamp tube, so it's like a boost. I'm going to also install it between stages, right in front of V2A preamp tube, so you can hear the difference and see how the amp reacts depending on where you put it. So I'll have demo clips of both ways. I'm also going to, after that, I'm going to show you some small circuit tweaks you can do to the amp if you want to add even more gain on top of the Add-a-Stage to get a little bit more little gain and compression out of it. And I'll do clips of that too, so you can see what it's like. Okay. Also remember throughout this demo, this is stock 2203. We're just throwing a gain stage in front. It's not going to be super high gain, the highest gain amp in the world, but it's really cool because it retains that Marshall DNA. It keeps the crunch, it keeps the openness, keeps the top end bite. It's, for guys that don't want to lose that sound, but just want more of it, this is a perfect solution. Now you can do more circuit mods to the amp, or you can take a modded amp that has more gain already, and you can add the Add-a-Stage and get a super high gain. It depends on what you want to do, and this is just one example of installing one in one type of amp. There's many possibilities out there, obviously, but I can't do an install video of every amp that exists, so it's just going to be this one for now. One thing I want to touch on is I've gotten a lot of questions about the Add-a-Stage board, and one that keeps coming up is how does this differ from one of those modules that you can plug into a tube socket and get extra gain? You know about those ones that you just plug right into V2A, and it's got a little gain control on it. It's a little box with the two tubes on it, and you get extra gain, which is super cool. It's an awesome idea. I think it's great. Super convenient. You don't have to wire anything. There's no technical knowledge as far as opening an amp up and getting inside of it, or having to have a tech install something for you. The Add-a-Stage obviously involves a little more legwork. You got to actually get in the amp, open it up, and it should only be done by somebody who knows what they're doing with tube amps and can work around high voltage or an amp tech. But what's the advantage of this, or what's the difference? Well, for one, it's completely configurable, right? So every component on this board can be changed to different values. So the plate resistor, the input grid resistor, the cathode bypass, the voltage divider, all that stuff can be changed and configured. The filtering can be changed to your particular amp and to what you want to hear. You can experiment with this and have fun. I mean, you can, open the amp up, play it, change one value at a time, alligator clip stuff, change values and see how it sounds. It can be a lot of fun to do that, and you can get your tone and get exactly what you want to hear out of the amp instead of having a preset circuit that just plugs in. The other advantage is you can choose where you put this in the amp. You can put it up front like a boost in front of the first preamp tube. You can insert it between stages. You decide where you put it, and that's another big advantage. The other is cost. This is right now currently a fully assembled board ready to go is less than a quarter of the cost of one of those units that plugs into the amp into V2A spot. So that's a big difference right there as well. But I think the main thing is just for the do-it-yourself guy, or somebody who wants the flexibility of actually making the amp sound exactly the way they want it to sound. You can't beat this for the flexibility and the versatility of being able to change all the components. Okay, so we're going to do the install. We're going to talk about everything from beginning to end to install this thing in the amp. So by the end of this video, there should be no problem putting this thing in an amp. We're going to do demo clips, several of those, and then I'll give you my final thoughts and everything at the end, how I thought about or what I kind of took away from the different positioning of the Add-a-Stage in the amp. And that's it. So any other questions, just shoot me a line, shoot me an email, or check the website, and we'll get on with the install. Okay, we got the chassis out of the head shell on the bench, ready to go. What's pretty cool about this amp that you don't see too often with these is it's got a blue PCB board. This is the second Marshall I've had come through here with one of these. They're pretty rare. You're obviously used to seeing a green PCB board, and this looks almost like an aftermarket replacement, but it's actually a factory board. And if you look here, it's got the Marshall ST1 silk screening, and all the rest of the silk screening is, you know, factory Marshall stuff. It's got the 50 watt, 100 watt designation and all the component values and where the placement is on the board. I don't know what the story is with these. I'm assuming that at some point the manufacturer of these boards ran out of the green material and had to source a different material that ended up being blue, and they made a limited amount of these with blue boards. But I think it's super cool and it's rare. And yeah, it's the second one I've seen in many years. So there's not too many of these out there. But otherwise, it's completely, you know, the same as any other Marshall. So for our purposes, you know, just this will apply to any Marshall of this era. Again, this is a 79 JMP 2203. So what we're going to do is we're going to do several things. We're going to talk about one, installing your DC power supply to run your relay and potentially your heaters. My opinion is if you're going to install DC supply, you might as well install one that's going to run your heaters and your relay at the same time. There's no downside to having DC heaters. It's going to be quieter, less noise on your preamp tubes. Second thing is we're going to talk about replacing the inputs or updating the inputs on the amp. So the stock inputs are all unshielded wire, just this regular type wire. You have a hot shield right here, or a shielded cable. It's, you know, very short run from this resistor to this grid in the tube. But the inputs at bare minimum have to be replaced with shielded coax cable, because these circuits are really on the borderline of being unstable as they are in stock form. Like if you come over and take the cold clipper and drop it down to say 2.7K, you know, or some lower value to raise the gain is very common on these. Sometimes just cutting that in half to, like, you know, putting a 10K over it to make it 5K will make the amp instantly go into oscillation. I've had that happen before on stock ones. So they're really pushing the envelope as they are with the input wiring. There's no shielding whatsoever other than this, which, you know, is just a small portion of it. So we'll talk about replacing the inputs. You're going to need to do that when you're adding an extra gain stage for sure. The DC power supply, and then we will talk about mounting the actual Add-a-Stage. This one isn't assembled, but we're going to put an assembled board, mounting it right over here like this. So we'll talk about how to space the hole for the new tube, and determining where to put that, how to drill it out, and then how to drill the holes for the board and mount the board. And then we'll do the full hookup, wiring it for B+, heaters, the inputs, all that good stuff, and we'll make it a fully functioning fourth stage. We'll also talk about adding switching for the board, how to switch the stage in and out. I'll probably do foot switching on this one as well, just to show you how it's done. So I'll likely switch it with a push-pull pot on the gain control. So we'll replace the gain control with a push-pull pot, so you can switch it from the front without a foot switch. And then I'll probably put a foot switch jack back here, so you can do it with a foot switch as well. And when the foot switch is inserted, it'll override the switch on the gain pot. So no matter where the switch is set here, the foot switch will ultimately take control once it's inserted into the amp. So you'll have both options. So if you want to do that, you can. I'll show you how to do it. Or if you just want to, you don't need a foot switch, you can just do it with a push-pull pot here, or you can, you know, use a toggle switch or whatever. But this allows you to add switching without drilling any extra holes into the amp, if you don't want to do that. But it's entirely up to you. But we'll talk more about that when we get to it. Again, with this amp, this is bone stock. But what I recommend doing, which I did in this one, is replacing the filter caps with new filter caps if they haven't been replaced since new. I put new screen resistors on this one. Clean the pots. I cleaned all the pots. Just use some deoxit. I'm sorry, this is the wrong one. I meant to show you the difference. This is the one you want for pots, is the deoxit fader spray, the green can. You don't want to use regular deoxit in the pots, you want to use fader spray. So this for the pots, and then clean the jacks. On an old amp like this, use the regular deoxit to clean the jacks, input jacks, speaker jacks. Just get all that stuff up, you know, and maintained, so you're starting with a strong base for applying the mod. So yeah, the next thing we'll do is we'll go into DC heater supply units. So this is the one I typically use right here. This is a pretty good size supply. It's a heavy duty supply. It's quiet. It's a really good supply. This one is made by Meanwell. It's Meanwell. And the part number on this one is, it's EPS 6512. Okay, they make a smaller frame version as well. This is probably, I don't know, 2/3 the size. It's the EPS 65S12. It's more compact, but the problem with that one I've had in the past is it makes noise, it whines, and it will transfer into the tube circuit, and it'll amplify, and you'll have a hum that's really annoying. So I stick with this one if you're going to use this version. So this one, where I mount it typically on the 2203, is I put it over here in this empty space. It fits right over there. I'll put standoffs, and it'll sit out here. Works really well. It sits below the surface so it can fit in the head shell. There's not a lot around it. The transformer wires are there, but it doesn't cause any problems. If you have an amp with like a lay down mains transformer, so you'll have the transformer sitting right here. You can't put it here, it won't fit because of the mains transformer. So what I've done in the past is I actually mount it above the filter caps. I just double up the standoff so it sits up higher. It can be a lot more of a hassle to put it in, but you got to do what you got to do to make them fit. So you can put it here. A 50-watt chassis is a bit more of a challenge because you're really limited to space. So most of them you can fit it. Most of them you can fit it here on this side where I put them on the hundreds, but not all of them. So you just got to work with what you have and hopefully make it fit. So this is my preferred way of going with DC heaters. This one has no problem powering the preamp tubes and also your relay. The other option, if you don't want to install that one, is a much, it's basically easier to install, is a small box. It's made by Recom, RECOM. This is the RAC2012SK. So another one of my customers, Brandon, recommended this, and I said, that looks like a good unit to try. And so I ordered one and I tested it out today, and it actually works really, really well. So it just takes, same as the other one, but you just have your AC voltage come in here and then your DC voltage comes out here. Very simple. So something like this, I haven't mounted one of these in an amp yet, but I mean, it takes up hardly any room. You could stick it really kind of anywhere, and it doesn't take up much room at all. So if you have very limited space, this could be an option. I think the output on this is like 1300 milliamps, so you shouldn't have any problem driving the preamp tubes. I haven't tested it on the preamp tubes and the relay, but I did power the relay with it earlier today, and I had no problems. It worked perfect. But I think it won't have any problem powering preamp tubes as well. So the thing with this one is that there's nothing to mechanically mount it to the chassis like the other supply. So this one you'd have to do like maybe some of that 3M extreme duty double-sided tape and stick it to the chassis, and that stuff is really strong. So I wouldn't have an issue really using that, as long as your surfaces are clean and you put a good amount on there and press it down and hold it. It should stay in there pretty good. So we'll talk about this one. Let's start with this one first, because this is the one I'm going to actually install in the amp. Let's do the actual install on this one, and then we'll wire it up. So let's talk about how to wire this thing. So there's two sides to it. There's the input side, which is these two terminals here. And there's the output side, which is these four terminals here. So you're going to run 120 volts AC, or depending where you are, if you're in Europe or another country that has different voltage, this unit will take, I think it's something like 80 volts up to like 285 volts. No matter what you put in AC, in that range will come out as 12 volts AC, DC over here. It's really nice because you can use an amp in the US, use it in Europe, wherever, and despite what the input voltage is, it'll automatically regulate it to 12 volts DC. And it's, every one of these I've checked, and after I install them, they're like exactly at 12 volts. And also has a trimmer here. This little trimmer, you can adjust the DC voltage up or down. So if you wanted like 12.3 or 12.6, I just leave it at 12 volts, is fine. So there's two pins here. You gotta, let me put it back in frame. There's two pins here. Just pay attention to the polarity. So this bottom one, there's a ACL written on the board back there. I don't know if you can see it, but ACL is AC live. and there's ACN, which is the top one, which is AC neutral. So what I do is wire this to the power switch so that it's switched power that goes to it. So obviously when the power switch is off, there's no power going to it. Flip the switch and it gets 120 volts AC across these two terminals. So on your power switch, you can see here we have the neutral wire, the white one coming in. The black wire, the hot, goes to the fuse and then comes back into the switch on the other side. So you have hot here, you have neutral here. So we're gonna run a neutral wire this side. On the bottom, this is the switch terminals, and the second set of terminals on the bottom is the switched ones. And these top ones are the live that's coming in straight from the wall. So we don't want them on these terminals where it's coming straight from the wall, or it'll always be powered. Got to have them on the switch terminals down here. So you gotta pay attention to where the live and the neutral are coming into, because this could always be switched around backwards. You never know. Someone could have flipped these around at some point. So just pay attention to which one's live and neutral. So once you determine what those are, run the live here, this bottom terminal, neutral up here. Okay, and then you're gonna have your output. It's gonna be your 12 volt DC negative on this side. These two top terminals do the same thing. And the bottom two terminals here are 12 volt positive DC out of here. So the way you're gonna do it is you're gonna run one positive lead to one side of your preamp tube heater. So we're gonna use pins 4 and 5 only for DC heaters. We're not gonna use pin 9 anymore. We're gonna use 4 and 5 only. Okay, so you're gonna run, what I do is run a positive, come around here, run a positive from here to pin 4. I always put positive to pin 4, and that's gonna be useful for the board as well, because that's where the positive needs to go. So this one to pin 4, leave this pin unhooked, this one. This one, you need to run to a chassis. This one right here, you need to run to a chassis ground, okay? Because we need a ground source for our heaters. And then this one here, the top one, I run to pin 5 on the heater. So pin 5, ground, no connection, and then pin 4 on this one here. Okay, so I'm gonna start drilling holes over here. Let's see. I'm gonna start drilling holes over here for mounting this thing. And what you can do is you can put this board on the backside, on the backside of this area that you're gonna attach it, and use it as a template with these holes. Hold it against there and mark your holes and then drill them, and then you can attach it. It's useful to take this cage nut out so you can place it. So I'll take that out, I'll hold it against here, I'll mark my holes, I'll drill the holes, and then I'm going to use standoffs like these aluminum standoffs. They're gonna go between the chassis and the board. So it'll stand it off from the chassis, so you have some space from the back side of the PCB. So I'm gonna get started drilling some holes here. I'll show you when it's mounted, and then we'll hook up and wire it. All right, now I've got my DC heater unit mounted to the chassis. You can see it's mounted with these standoffs. So I just drilled holes to the chassis on this back side using my unit as a template, and then installed these standoffs, and it's screwed in from the back side, and the board is screwed in from this side of the standoffs. These are aluminum standoffs from Mojo Tone. They're, if you look up 440 by 1/2 inch aluminum standoffs, they sell these in packs of 12. They're really handy to have. They're threaded all the way through with 440 threads. So get these, and then 440 screws, and you can come in from either side. I use lock washers also on the, like an internal tooth washer on the chassis, on the outer chassis side, so they won't come loose. And then you can also see that I've now run my wire down here from the power switch, secondary side, the switch side, to the AC live and neutral side in here. And obviously when you're doing this stuff, make sure that the amp is not plugged in, it's turned off, the filter caps are drained, there's no power in it, before you start playing around with this stuff. And make sure you know what you're doing. Obviously, if you don't know what you're doing, don't be working on this stuff, and let a tech do it instead. The next thing we're going to do is we need to wire the secondary output side of our DC unit. So we have the power coming in now, we have it mounted. Now we need to go to these terminals over here that I showed you earlier, the 4 terminals, and we need to run our wiring over to the power tubes. I'm sorry, the preamp tubes. Okay, so I've already removed the stock AC wiring from the preamp tubes. You can see here. So the last place that the heaters are now running are from the power tubes over to the phase inverter tube. It's still getting AC power for the heaters. We don't need to worry. We need to worry about running DC on the phase inverter tube. It's not going to be useful. It's going to cancel itself out. It's 180 degrees out, so it's not going to give us the benefit of having DC. So just worry about, you know, the V1 and V2, and then ultimately our extra stage, our extra tube will also get DC over here. Okay, so again, we're going to utilize pins 4 and 5 right here. Zoom in a little bit. We use pins 4 and 5. Pin 9 down here is disconnected now. We're going to leave that open on both tubes. Okay, so again, what I referenced earlier on that DC unit, I showed you where to run pin 4 and 5 from. So pin 4 is here, and pin 5 is here. It's going to run from those terminals. So what I'm going to do is I'm going to run wire 2 leads for my DC heater unit, my 12 volt positive, my 12 volt negative, out across the back into this first tube. Then it's going to be daisy chained across into this tube, and I'm going to run another daisy chain across for both leads out to here so that I have power for my Add-a-Stage board. So I'm going to wire those up right now, and when I do, I'll show you how that looks when it's all done. The other connection we need, besides the 12 volt negative and positive out of here to the tube, is we need a chassis ground to the pin I showed you earlier in the video. The best place, if you're going to leave the amp stock, what I would do is run that. It's going to be a long run, but I would run that chassis, that heater ground, all the way to this bus bar up front, and I'd run it about up here, about this position here, because this is about where the power tubes are in the chassis. So I'd run it here. It's not the most ideal thing in the world. Ideally, we'll change all the ground points in the amp, which is what I'll do to this amp eventually when it gets an actual sniper mod. Is I'll redo all the ground points across the front of the chassis, and each section of the amp will have its own ground point instead of just having this bus bar, which, you know, it's fine for a stock amp, but it's not ideal for a modded one. But that notwithstanding, let's just run it from here and put the ground to here. So that's what I'll do for now. I'll just run the ground here, and then I'm going to wire my heaters up, and I'll show you what that looks like when that's done. Okay, the DC secondary side, the output side's wired up. So I've got my negative and positive, my negative being the black, positive being the red, coming out of the unit at the top and bottom terminals. And then I have my ground lead coming out on the second pin down. And then my ground's running all the way here along the front of the amp, and I have it connected right here. So I'll be pulling that out later because, like I said, I'm going to redo the grounding for the amp. But if you're going to leave it stock, that's where I'd put it. Okay, the preamp tube heaters are now wired. So as you can see, I have the positive red running to pin 4 and the negative to pin 5. And pin 9 is still open. And so these are my wires coming in from the heater unit right here, red and the black. And I'm just daisy chaining across to the next tube. Both leads are daisy chained to pin 4 and 5. And then I left these leads here so that we have a heater source for our Add-a-Stage. So when we put this in later on, these 2 leads are going to come right in here to the board where the heaters go in. It's going to be nice and easy to connect that, so we're ready to go. Okay, so let's talk about the smaller DC unit board. I'm sorry, supply. That's this one again, the Recom, which I think is a really cool unit. I mean, it really works good. So with this one, it's marked on the top. It's pretty easy. It's got, we'll start on this side. So this is L and N. So it's got live and neutral. So live and neutral, which corresponds to the 2 really small pins in the back. These 2 pins here are going to be your input, your AC input. And this one, like I said, will take, I think, 100 volts up to 240. So Japan, US, EU, it's going to work pretty much anywhere with all voltages. And then your secondary side, your output's going to be your, it says V plus here, your DC positive, and then your DC negative. This automatically regulates to 12 volts. It's the 12 volt. The 12 SK means it's 12 volts. They have different versions. They have like 5 volts, 10 volts, different stuff, but you want the 12 SK. And right here it says 100 to 240 volts. That's your input. Your secondary 12 volts right here, DC. Okay. And then these are your output pins in the back. Again, they're labeled here so you can reference which one is negative and positive. So this is wired essentially the same as the bigger unit that I just installed. It just has 2 less pins on the output. And instead of having 4, it has 2, which is all you need. So on this one, you'd run your positive and negative to your tube, and then the negative side also needs to go to ground, and then your AC on this side. But that's really it. I mean, with this one, if you want to use it, especially for just powering the relay, if you want to use AC tube heaters and then just power your relay, this is a quick, easy way to do it. And I think they cost about 15, 16 bucks. They're not too expensive. You just got to find a place to mount it, but it shouldn't be too hard to do. All right, so the next thing I'm going to do is I'm going to start working on I think we'll start working on installing the board. And then once the board is installed, we'll work on changing the inputs over to shielded coax, since we're going to need to run an input to the board anyways. Might as well do that then. So give me a second and we will start drilling holes and marking things for the new tube. Actually, yeah, I'm gonna show you how to mark or how to find the right placement for the next tube. We want to keep this equal spacing, right, for the next tube. We want it to look right and be equal spacing from the back side of the chassis, and also equal spacing apart from each other. So that'll determine where this board's going to land. And what I did with this board is I added a hole here in the PCB. This is specifically for using it as a template, so you can center it in the chassis. It's useful. It's easier to do it with an unpopulated board because it's flat and you can just lay it against the chassis to mark the screws. But even if it's populated and it has a tube socket in it, you can still, the tube socket also has a hole, so you can stick like a drill bit or something down through there all the way through, and you can still mark the chassis even if it's assembled. So either way, you can still use it as a template. But I'll flip the chassis over and then I'll show you how to mark the tube. I like to do it from the other side, the top side, rather than this side, so I can get the depth of the tube in the right spot. We'll drill a pilot hole for the tube, and then we'll use that pilot hole as a reference for this hole. We'll line it up, and then we'll drill the 4 chassis mounting screws for the board. All right, so we got the chassis flipped over, so we can start marking our new tube hole. Get yourself a ruler like the 6-inch machinist rule. These are super handy for marking where you're gonna drill on chassis. It's using the millimeter side for me is the easiest way to do it. But take the metric side and measure the distance between your two tubes, because you want to keep the same spacing, right? And these are typically about 63 or 64 millimeters in the Marshall. You can measure from rivet to rivet because that'll give you the equal spacing, or you can just go from the center of the tube to the center of the tube. And this one is right about like 64 millimeters is what I'm going to call it. Okay, so we want the same thing for our next tube. So we're going to put this in the middle, start it in the middle of that tube. I'm going to come over to 64 millimeters. I'm going to mark it there. Okay, so I just use a Sharpie to mark that 64 millimeters. Then we need the depth of the tube as well, because we want that to be the correct spacing. So what I do is measure from the very edge of the faceplate in the back to the center of the tube. You can just pretty much eyeball it, and that's looking about 31 to 32 millimeters. We'll call it 31 and a half. So I'll come in here, and I already have my axis. I need this axis here, so we're gonna go up to 32. I'll mark that with an X or a plus sign, however you want to call it, and we'll just drill in the middle of that. What I like to do before I drill a hole, just to double check, is I like to stick just a regular tube socket on there and use the hole to look through it, and that reference that mark I made and see how it looks and make sure it looks like it's lined up, and it does. It looks really good, equally spaced. It's spaced correct front to back, so I think we're good. So what I'm going to do is I'm going to drill a hole right in the center of that X mark. I'm going to drill an 1/8 inch hole, and then once I drill that hole, I'm not going to go any bigger. I'm going to flip the chassis over, and I'm going to use this hole from the board to center the board where it needs to be, and then drill the mounting holes. Because if I drill this thing out to the full size of the tube socket, now I don't have a way to reference where the center is in relation to this hole. It's going to be too big. You're going to be going around like this. So I'll drill this hole. We'll flip the chassis over, and then we'll mark the mounting holes. Okay, so we got the chassis flipped back over again, And what I've done is I've taken an unpopulated board, and I have taken the hole to use as a template between the tube socket area, and I've centered it over the hole that we drilled in the chassis, the 1/8 inch hole. You can see the hole right there in the middle. So what that's going to do is that's going to give me a center line, so that when I drill the hole bigger, the board's going to line up perfectly so the tube socket can pop through the chassis. Now you also want to line the board up, you know, side to side, and so it's straight back and forth in the chassis in relation to the PCB board. So once I have that square and lined up, I'm going to hold it down, don't let it move. I'm going to take a smaller point Sharpie, and I'm going to mark the 4 holes for mounting the board. This is a super easy way of installing it nice and straight in the amp. It takes all the guesswork out of it. So what I'm going to do is drill these 4 holes, and then we'll I'm gonna take an assembled board, which is this one here. I've already built it. It's going to go like this. Okay, once the hole's drilled big enough and we can get the tube socket through it, it'll obviously sit down lower and we can put the standoffs in it. We'll put this one in next. So I'm going to drill the holes. I'm going to use the same 440 1/2 inch standoffs that I referenced earlier that you can get from Mojo Tone. They're threaded internally, and 440 screws. And what I'm going to do is, after I drill the hole, I'm going to come with a screw from the top side of the chassis in and screw the standoff into that. Okay, and I'll have 4 standoffs screwed into the chassis, and then I'll set the board, the PCB board, down on the chassis, on the standoffs, and then screw that into the standoffs from the top. So screw from the top, screw from the bottom, and the standoff in the middle. Okay. Okay, real quick, I've got the 4 holes drilled for the standoffs. These 4 here that we're going to use to mount the board. Before we put the standoffs in, I forgot we got to drill the hole bigger. So let's drill this out for the tube socket, because that hole has to be there for the socket to go through. We're never going to mount the board. So this hole with grab one, with the shielded tube socket, this hole needs to be 30 millimeters or 1 3/8 of an inch. And what I use actually 2 different step bits. So I'll probably drill that hole out to about, I don't know, maybe 3/8 of an inch with an actual drill bit. And I'll come in with this step bit and take it out to wherever this one goes to, 7/8 of an inch with this one. And then I will come in with this big boy right here. And you can see where it's worn down, because that's where I usually go to right here. It's just over, well, it's actually not all the way to 1 3/8. It's just past 1 1/8. So whatever the next step is on this next, past 1 1/8. But it's approximately 30 millimeters. But that's where you need to drill it out to. So I'm going to use a combination of a drill bit and 2 step bits. I'm going to open that up, and then I'll show you what that looks like. All right, we got our big tube socket hole drilled in the chassis, nice and clean. I went from the top in with the step bit to drill the hole, and then once that happens, your hole here is going to be kind of rough. So you can come back down on this side just lightly to chamfer that hole to clean up the edges and make it nice and clean, so it's not so rough looking. You're not really going to see it anyways when the board's in, but it's nice to have it cleaned out. Okay, I also installed my 4 standoffs. Okay, so again, it's screw. Well, I do screw lock washer from the top, standoff, and then we'll come with a screw again for the top for the board. And then what I also went ahead and did was to install a ground lug here. This is a good spot to put a ground point for this extra stage. I would put an extra one here instead of running it to the regular ground bus. So I drilled an 1/8 inch hole, and I used a 440 screw, a 440 nut, and then just a ground lug. So that's where we're going to put the ground for the board. Okay, so here's our board. We're going to put the tube socket through the hole, and then I have my heater wires just hanging here ready to go. So what I'm going to do is I'm going to line those up. Okay, again, this is your positive DC, and that's going to go to 4 right here. Okay, so pin 4, and the reason I keep referencing pin 4 for the positive is because pin 4 has a jumper here that jumps pin 4 across the board and into the relay. So it automatically provides 12 volts DC from the heaters to the relay, so we can power the relay without having to run a separate lead. So if you're running AC heaters and you're using a separate power unit like that Recom unit that I showed you, then you would run the 12 volts in right here where it says V+, and this will power the relay even though you're using AC heaters. So this is where it would go. This is the ground for the board right here. GND is ground. Here's a chassis ground pad. This can be a little confusing, so don't confuse this for where you ground the board, because this just goes to here. So when this board is screwed down to the chassis, it grabs chassis ground here, and here's a chassis ground supply if you need it here, but we're not going to use that for the install. Use this ground point right here to provide all the ground to the board. And this will provide all the ground points throughout the board are going to come from here. So we're going to hook up our heaters, in this case, pin 4 positive DC, pin 5 negative DC, so red and black for our heaters. We're going to hook up ground here. We're going to grab B+, okay, for our to power our plate of our tube. And where I'm going to grab B+, the best spot to do it is just come off the B+ supply into the first stage plate resistor. Either one of these two first stage plate resistors, it's the same thing. These two points here. Move this out of the way. But this here and this here are tied together, the same place, and they're coming from the one side of the preamp filter. Okay, and so that'll provide enough voltage to power the board. So what I'm going to do is I'm going to tie just run a lead, a wire from here down and across. The board's going to be here. Here's the B+. Put this out. The B+ pad is here. So I'm going to run a wire from here, nice and clean under the board, and then come out and up into this B+ pad here. Okay, so I'm going to run that, put my heaters in here, my ground here, my ground here, B+ here, 2 heaters here, and then at that point we're down to just running our switch wire to switch the stage in and out to activate the relay, and then our 2 inputs. So this is our main input where it says input jack, and this is the ground for that wire. So these 2 are for the input, and then this is another input wire that's going to go to the next stage. So your input into the gain stage comes here, and then back out from here to the next stage that you're going to put it in front of. We're going to put this right now. We're going to put this in front of the preamp. So we're going to put it in front of the stock first tube. So this would be pushing like a boost in front of the amp into the first tube. What I'll probably do also in this install video, after we're done doing that, and we'll do it like a demo clip with the stage in and out to see the difference of how the amp sounds with this in front, is I'm also going to wire it. So I'm going to insert this extra gain stage between V1B and V2A. So you can do that with this board. You don't have to run it just in front. You can run it also in between stages, which is pretty cool. And it depends on the amp, but sometimes I really prefer the way it sounds put in between the stage instead of in front. So we'll see if we can tell a significant difference in clips. I'll make 2 clips, one with the stage in front, one with it in the middle. But it's really simple. And actually, once you install this board and you have it in front, if you want to switch it around and run it in between stages, it's not really hard to do. And I'll show you how to do it. It's pretty simple to test if you want to do it. So I'll just show you real quick how I'm going to do this. I'm going to lay this board in here and see if I can get around and put these wires in. Set these wires in here now before I put the board down. Okay, I'm just going to set the board down with that tube socket going through the hole. And then I'm going to line up my standoffs with the holes. I'm just going to grab a screw. Stick a screw in here. Start screwing the board down. Come to the opposite corner and get that one in there. You can see how clean that installs. It's super nice. I mean, it's so clean. You don't have a ton of loose wires hanging out. The board is completely ground shielded, so you have, lower noise floor. Everything's self-contained. And the hookup is it's extremely easy. I mean, it really is very, very simple. It's just a couple of hookups. So I've got the heaters in there now. I'm going to solder those in there into their pads. I'm gonna run the ground wire that I talked to, the ground into the board, this pad here right next to this filter. I'm gonna run that to this ground lug here. Okay, so the ground's gonna go to this ground lug here. And like I said, the B plus, I'm gonna pull from this resistor, the B plus side, to this B plus pad here. So I'll do that and then we'll come back. Okay, so I've got those connections all made. So I've got my heaters wired in, soldered in here. Okay, I've got a B plus pulled from right here at this plate resistor across this black wire down under the board, and then pops up into here into the Add-a-Stage, into the B plus entrance. And then I've got the chassis ground here running here under the board into the ground pad here. Okay, so we're almost done hooking this thing up. All we have is the two inputs, or the input, the output, and the switch, and that's it, and we're done with that. Okay, the next thing we need to address is the input wire situation. Like I talked about earlier, the amp is on the borderline of, you know, oscillating and being unstable as it is stock. So we need to shield the inputs from the additional gain that we're going to have. So I'm just pushing this down. This is for the phase inverter. So the three inputs we're going to deal with, or the first three inputs. So we're going to go this grid here, this green wire. Then we're going to deal with this grid here, this hot shielded cable, and then this grid here into V2A. So those three wires we need to remove. I'm going to remove this wire from the tube and also from the board here. Same thing with this shielded wire. Take that and toss it, and then this green wire needs to come out and get removed from the board here. You can let me see if my soldering iron's hot. You can actually remove these wires from the top without too much effort, without having to lift the board. I'll show you how to do that. If you just, you can see part of the wire sticking up above the board, a little bit of the bare wire. Just get that hot. And once it gets hot, well, insulation tore off. Just let it get hot enough till it's loose, and you can just pull it right out. And we don't need to put anything back there, so it's not a big deal. And what I do is just come in here and trim that off. And you can pull it down through the board and it's cleaned out. Okay. If you need to clean this, there's some residue. You can use acetone, works really well. And then just come to this side and pull this off. And then we'll clean up these pins so that we can resolder new inputs. And so for example, on this input, you know, that one green wire we just removed is coming from these 470K mixer resistors here, and through the board to here, and then through the wire to the grid. So what we're going to do is we're going to run a coax straight from the 470 straight to the tube grid. That way we're completely shielded all the way through. Okay, and then this one is from the input, the main input. So we're going to bypass this and run the main input to the board, the Add-a-Stage board. So that inserts the stage in between the input and the first stage. So we'll run shielded cable from the input, which is this wire here. This green wire is going to the stock high input jack. So we'll remove that from the input jack, because this is no shielding on it whatsoever. We'll remove that from the jack and from the board. We'll replace that with shielded coax going from the high input jack to the input jack input on the board. The board has ground on it, so you can run your input and your ground here for your shield and your cable, and then run just a single input to the input side of your jack. You don't need to run a shielded part to the jack. It's already here on the board, so that makes it easier. And then the last one we need to deal with is off the gain pot wiper, is this wire here, which is ridiculously long, and it's just, you know, picking up all kinds of stray frequencies in the amp and can oscillate. So that goes from the gain pot wiper, okay, into the board, then through the board to this green wire here, and then from that green wire into the grid there. So we need to remove this as well. So those three, so the V2A grid, V1B and A grids, remove those. The gain pot wiper wire, remove that. The input wire, remove that. And then we will replace everything with shielded coax, and I'll show you what that looks like in just a minute. All right, I've got all the input wires that we talked about removed off of the first three grids, and also off the gain pot wiper and from the input jack and the ones that ran across the board. So those are all removed. But before I get to installing the actual input wiring, I want to stop and go over some other stuff I did in the meantime as far as switching for the board. So we know that we have to, our switches run right here on the board. SW is a switch, okay? And to activate the relay, you apply ground to this pad where it says switch. And what we want to do is we want to have the board normally grounded when the amp starts up. So when it's normally grounded, it's going to bypass the stage. So your input from your input jack is going to come out into the board here. It says input jack. It's going to bypass all this extra stage. And it's just going to go right through to this pad and then back out into your first gain stage or normal gain stage. So just like your amp was before you ever put this in the amp, it'll be right back to the way it was. Okay, we want the switch normally grounded for that. So whatever switch you have hooked up to this needs to have ground to it. Well, in this situation, it's a switch gain pod I put in here, and pushed in, I want it to be normally grounded so the stage is off, and then pulled out, it's going to activate the stage. Or you can do it, you can reverse it really, and you can have the stop with it out and the higher gain with it pushed in, but it's kind of counterintuitive that way. So I'll show you how I wired it. So to get the normally grounded setup, I removed the stock pot and I replaced it with a switched 1 meg audio Bourne's pot. These are really good. They have a 3/8 bushing, push-pull. They're pretty reliable. So everything else is hooked up the way it was to stock. The input, the bright cap is back on it, the 1000 picofarad bright cap. I haven't wired the output from the pot yet, but I'll do that here soon with the shielded cable. The ground is back in from the normal spot. Okay, in the switch part, so you have your 3 terminals for your switch. The center being the common where I have ground coming in here. I'm sorry, ground is here. Okay, I have a lead across those 2 terminals, and then it's grounded to the side of the pot right here. So it's grounded here. And then that is connected to this middle wire when the pot is pushed in. Okay, these 2 are connected. When the pot is pulled out, this is now connected to these terminals, which are open, so it's going to remove the ground, and that's going to cause the relay to switch. Okay, so grounded when it's in, no ground when it's out. So relay will be bypassing the extra stage pushed in and then activating the stage when it's out. Okay. So if you're not running a foot switch jack, you would run that wire from the center lugs directly to the switch pad on the Add-a-Stage. Okay, so that way it's giving it ground when it's pushed in and it's bypassing the stage, and then when you pull this, it'll remove ground from the switch because this will no longer be grounded. It'll be to the front terminals, and you're going to activate the 4th gain stage. Okay, in this scenario, what I did is I added a foot switch to the back panel. Okay, for this one, I'm using just a regular switched like Cliff input jack. Okay, with 4 lugs on it, 2 on each side. It's got to be a switched jack. Okay, so instead of running my switch on my gain pot here straight to the board to the switch, I'm running it to the foot switch jack. Okay, it's going to run to this terminal here. So the switch on my gain pot is running to this terminal here. Okay, this terminal here is not connected. This back terminal here needs to go to ground, chassis ground. What I did is I ran a wire down here under the board and I ran it to this chassis ground pad here. So that's actually useful for that. So that's giving ground to the foot switch jack. We don't need to worry about ground loops with this, just the foot switch jack. It's not going to affect anything else on the board. So we can use this and run it straight to that. This terminal here, this lug, is going to go to our switch pad. Okay, so when a foot switch jack, foot switch plug is inserted in here, it's going to break the contacts. So this will no longer have contact from your gain pot, and this is going to control the ground to the board through your foot switch jack. This will no longer be connected. When you remove that plug, that closes the switch, and now you're going to get control from this terminal, which is connected to your gain pot. So your gain pot is now going to control the stage being switched in and out. So The other thing is when you plug in a foot switch jack, it bypasses the game pot. So regardless of what position this game pot is, the foot switch will take over control of the board. So that's how you wire the switching. If you don't want to use a game pot and you want to use a regular switch, it's the same idea. Okay, you have your 3 terminals on your switch, and you just wire your common, and then you have ground on one side and no ground on the other side. And one side of the switch will activate the relay, and the other side will add or remove the stage. And so now I'm going to go install the inputs, and I'll show you how those look when they're done. All right, here it is with all the inputs installed. We're at the end. This is it. So this is the last step of installing the board. So what I did is I ran shielded cables to all the areas we talked about before, the 3 grids, and then 1 into the board itself. So you can see here I got shielded coax going now from the high input here into the input jack pad onto the Add-a-Stage. Okay, so that's the way this works. So essentially what it is this Add-a-Stage is going between the input jack and the normal first stage. Okay, this is inserted in between basically, and when it's turned off, your input wire just goes right through to the first stage like it normally would when it was stock. When you activate the Add-a-Stage, the input comes in, it goes through the circuit of the Add-a-Stage, the extra tube, the extra gain, and then comes back out and back into that stock first stage. So you're just inserting the stage between that stock first stage. That's why we can take this and we can also insert it between other stages, which I said, we'll talk about later, and we'll do a demo with that too. We'll switch the wiring up and put it between V1B and V2A, which would be pretty cool too. So again, input wire from here, the high input jack into the input jack pad. Now this has a ground pad on it, right? So I shielded the cable from here on the board. So you don't need to shield the board over at the input jack anymore. Traditionally, I know that you'll run your input side, and then you'll run a ground on the other side of the input jack for your shielded cable. You don't need to do that because you have it right here on the board built in, right here. Okay, so don't ground it on one side or the other, but don't ground it on both sides because it'll create a ground loop and then you'll have a bunch of hum. So just pick which side you're going to ground it, and ground it from one side only, but not both. That's just one tip. Other tip on this board is when you wire these up, don't cut the leads super long when you put them in, because you don't want them going through the board underneath and somehow touching each other. And don't load this thing up with a ton of solder. You don't need to put more than just enough to hold the wires in, because if you put too much solder or the leads are too long underneath the board, they can connect and then you're going to ground out your input. So if you install this and you fire it up and you don't have any signal, come back here and check and make sure your inputs aren't grounded, because that could very easily happen. All right, so I've got that wire. Then the next wire I have is the output of the board, V1, P2, also has a ground on it. So we're ground shielded here, running out to our first stage, okay? And I put some grid stoppers on the tube here. It's a good idea to put some grid stoppers here. It helps with oscillation, any potential oscillation issues. You can put like a 33K or a 68K, should be fine. But I put one on each side of the tube. Okay, I didn't put one on V2A, but I put one on V1B and A. We used to have a hot shield here. So one added benefit to this is that removing that hot shield that used to be here that was shielded to the plate, that creates a lot of flub and dark, boomy sound in a stock amp. Even just replacing that in a stock amp improves the sound a lot. And I'd recommend it on the stock one to replace that with just shielded coax, ground shielded. The next shielded cable is from the gain pot, the gain wiper, out to the next stage. Okay, so that's also got a grid stopper on it there. Okay, so we got this here, and then I also put a shielded cable from the 470K mixer resistor out to V2A grid right here. Okay, so now our first 3 stages are all ground shielded. It's going to reduce any crosstalk or oscillation. It's going to make the amp sound great, and we're all done. That's it. I mean, I know this video is going to make it seem like it takes a while because talking about it the whole time and taking breaks in between. But in honesty, this is not a difficult procedure. It doesn't take that long, and the results you get for the amount of time invested are pretty significant. It's really good. I actually fired this amp up when I had the camera off, and it is pretty incredible how good it sounds with the fourth gain stage engaged. This is the first one I've put into a bone stock 800 or a 2203 circuit. It's a JMP, I guess, but same thing. All the rest of them I've installed have been on modified amps, Snipers and Moabs, and it works great in those as well. But this is the first stock 2203 I've put it in, and it's like, it blew me away when I fired it up and engaged the gain stage. It sounds really, really good. And when you turn it off, you don't want to leave it off. You want to turn it back on again because it sounds that good. So this is all wrapped up, ready to go. It's been tested and no issues. So next thing is going to be to put it on a speaker cabinet, fire it up, and we'll do some demo clips. One more thing I want to mention before I go into making sound clips with this amp is I made one more change to it, and that was raising the preamp voltage. I noticed the voltage had dropped to about, I think it was 310 volts right here at the phase inverter, which can be okay. It just depends what you like. But for me, I like it a little bit higher. So what I did is I went ahead and paralleled a 15K 3-watt resistor across the stock 10K right here to bring that voltage up a little bit. And now I'm sitting at about 325 volts at the phase inverter. I tried going a little bit higher. I didn't like it as much. I think 325 for this amp at least is a sweet spot. So you can dial that in there to where you like, and just listen to how it changes the response and the feel. But 325 on this one to me is just about perfect. Okay, still no clips yet, but I wanted to do one more thing. I just thought of it, and that's to throw the amp on a scope and see if how much gain we're actually getting out of this extra stage, how hard it's hitting it. And keep in mind that this extra stage is definitely gonna boost the front of the amp, and it's gonna be noticeable, but it's not gonna be super high gain, super chug style gain. We have a completely stock preamp, well, completely stock power amp as well for that matter. But all we have is an extra gain stage. We don't have anything else modified in the circuit, which would add gain. So we're just doing that one thing, but don't expect it to be, the most high gain death metal type amp that you can imagine. But it sounds really, really good. But that extra stage, the EQ is very consistent with the bass tone. Switching the extra stage in, it just gives it more of everything that it has. It tightens the bass a little bit in my opinion, and I think it has more clarity with the stage in it. But it keeps the EQ very, very similar, which is nice. So it's just more of what you had before. And it's very natural sounding. It's very, keeps the Marshall DNA. It keeps that mid-range, and doesn't sound like, something it's not supposed to be. So what I'm doing is I have a probe right now on the stock first stage out. So it'd be V1B coming out through this coupling cap here, and then into the low input jack, which would then go into the 470K, 470 picofarad in the gain pot, and then to the next stage. So right here on this first stage, without the Add-a-Stage activated, we are getting about 8 volts coming out of that stage. Okay, so I'm gonna pull the gain knob to activate the stage, and we'll see what happens here. And boom, we're hitting it pretty good. So we're now getting 28.4 volts out of that stock first stage now when we add the Add-a-Stage. So definitely hitting it pretty good. Let's put that back in. Let's check the next stage. So let's go on these 470 mixer resistors. This is becoming from V1A plate out and then into the 470s, which would then go into V2A. So let's see what we got there without the extra stage. We've got, I'm gonna turn the gain pot down to 7. So gain pot's gonna vary this, right? So this is gonna control the amount of gain going into the 470Ks. So let's just set up at let's put it at 7. And we got about 24 volts. And then notice the waveform. It's not really clipping yet, right? I mean, it's a little bit distorted. It's not perfectly round. We got a distortion in the waveform a little bit already. Let's pull the gain knob and add the stage. And look at that. So we got 44, just over 44 volts, and we can see the waveform really start to square off at the top, right? So we're getting more drive very clearly at that stage. So it's pretty obvious. It's hitting it pretty good. We're getting a good amount of gain out of the stage. So next I'm gonna set the amp up on my speaker, my 412 speaker cab with V30s. And I'm just gonna mic it with an iPhone because I think that kind of captures the sound in the room the best. And what I'm gonna do is I'm gonna play riffs back to back. The first riff will start with 3 stages, which is a stock amp. And then I'll have the foot switch connected, and I'm gonna hit the foot switch and switch over to 4 stages after each riff and go back and forth so you can hear the difference. So it'll start in 3 stages. It'll go to 4 stages for each riff, and that'll be the same way all the way through the video. Okay, now that we've heard what this extra stage is going to do up front, in front of the preamp, let's reconfigure this so that we can stick the Add-a-Stage right before V2A. So we'll put it between the stages. So we're going to put it between V1A and V2A. We'll just insert it, and we'll see if it's, you know, sounds different amount of gain, what kind of results we get from that. It's going to be pretty easy to do. It's not difficult. So once this is installed in the amp, if you want to rewire it for, you know, to be between different stages, it's really pretty simple. So the process is basically going to be is we're going to reroute the input wire. Instead of going to the Add-a-Stage, we're going to just put it straight to the first stage input, right? Because we don't want to put the Add-a-Stage in front of the amp anymore. So we're going to put another cable here on the jack, the high input jack, straight into V1B. Okay, and then V1A is going to act the same as it normally does now. Okay, it's going to come out this coupling cap here into the 470s, and then we're gonna insert the stage here where the 470s come out. So instead of going out from the 470s into V2A, we're going to go out from the 470s into the Add-a-Stage, and then out of the Add-a-Stage back into V2A. So you see what we're doing is we're just inserting it between where it would normally connect from the 470s to V2A. So we're going to disrupt this connection from the 470s to V2A. We're going to reroute it over to the input of the Add-a-Stage, and then V1P2 of the Add-a-Stage out is now going to go to V2A in. So I'll rewire those, and then we'll go from there. Here's the stage rewired to be inserted before V2A. So this took me probably, I don't know, 10 or 15 minutes. Pretty quick operation. So what we've got going on is I replaced the main input wire off the high input jack down here. I actually ran it under the board so that it wasn't up here crossing over the other inputs that we had to reroute to the other areas. So high input under the board comes out over here and goes into V1B. So That's coming from the input under the board. Okay. The next change is inserting the Add-a-Stage board, like I said, from the 470Ks. So I took the output of the 470K up here and ran that into the input of the Add-a-Stage. And then from the output of the Add-a-Stage, we're going into V2A. So that's it. Pretty simple operation to switch everything around. I actually just fired it up, and I think I like it better in the middle, or inserted between stages. I don't know. It's a little more aggressive. I think maybe it has a little more gain. It still sounds very open, organic, and Marshall-like, but I just feel like it's got more gain. I gotta compare it to the other clip I made of the stage in front. And I was using a different guitar and speaker cabinet to test it, but I have a feeling when I take it back and set it up in the same position and record it, it's gonna have a little bit more gain set up this way. So we'll do another clip, and then we'll see how that goes. All right, we're back on the bench with the amp after the two demo clips. I've actually put the amp back to the configuration where the stage is in front of the amp. I just wanted to do back-to-back testing and confirm what I heard after I tried it both ways. In my opinion is that it does sound different. I feel like in the front, the way it is right now, it's got a little more bass, a little woolier, you could call it. I think it's a little less aggressive. And when you put the stage before V2A and you insert the stage in this position, I feel like it's a little more aggressive, maybe a little bit more gainy, a little bit tighter. I sort of prefer it before V2A inserted between the stage. They both sound really good. So I would encourage anybody who's curious about that to try both ways and see what you like best. But that's my findings after trying both ways. So lastly, the very last thing I'm going to do is, again, this is in the stock Marshall. This is not going to be, crazy high gain, super tight, super saturated sounds. It's just adding more saturation, different feel, but it's still retaining the core Marshall tone when you install just the stage the way it is. And I think a lot of guys are going to like that because it keeps that stock Marshall DNA. A lot of guys don't want to lose that. They want that big open, cold clipper sound from these 800 amps. And other amps that are already modded that might have, additional mods for gain already, it's going to, it probably will be pretty high gain with those. And I think there's a significant difference when you add the Add-a-Stage, even in a stock amp. To me, like playing it, it's very obvious, especially when you switch it off and you go back to stock. You realize how big of a difference it actually makes. So it's very significant, don't get me wrong, but I just don't want expectations to be that it's going to be the highest gain amp in the world. So leading off of that, what I'm gonna do is show you guys a few things you can change in the circuit. They're really simple and easy to do. That if you feel like you just need a tad more gain, you can do that, and I'll even make a clip so you can hear it with these additions. So what I tried a couple things, like, you know, just basic stuff that we typically do to these amps. And what I found, a quick and easy way to do it is, one, we're going to modify the cold clipper, the 10K, right here. And I'm going to lower that down just a bit to get a little more gain out of the amp. But I don't want to take it too low because then it loses the character too much. It gets a little too buzzy and a little too compressed. So what I'm going to do is take a 22K resistor, and I'm going to parallel that over the 10K. And that's going to bring it down to right about 7K. I think it's like 6.8K. And what I found is it's a good compromise to add extra gain, but still really keep the character of the cold clipper without going too low and getting too buzzy. The other thing I'm going to do is I'm going to come over to the V2A cathode right here, the 820 ohm, and I'm going to bypass it with a 22 microfarad electrolytic cap. You can do whatever you want. You can put 0.68, you can put 1 microfarad, you can put 5, 10, 25 microfarad, whatever you want. I tend to like the way this sounds, this 22 microfarad. It's pretty good. It adds a good mid-range too, with a bigger value. So I'm gonna put that there on the 820, and then once you do that, and you add the gain here and you add the gain here, you're gonna start to get a little woolly in the low end. So we're gonna need to drop some signal out to compensate for that and clean it up. So the next thing I did was I took a 1 meg resistor and actually went from the wiper of the gain pot to ground. Okay, and that's gonna dump a little bit of gain out of the signal, and it's gonna clean it up a little bit. So those are the three things. So a 22K on the cold clipper parallel over the 10K, a 22 mic on the 820 ohm V2A cathode resistor, and then a 1 meg off the wiper of the gain pot to ground. So I'm gonna make those changes. I'm gonna put the amp back on the head shell, and I'm gonna make one more clip with these changes made, and let you hear how it sounds. All right, guys, that's the video. I hope that was helpful. Hopefully that helps, really lay out how to install this the best way in an amp like this. And it also gives you an idea of what it adds to the amp over stock. And this is a small example of, what you can put this in. I mean, this will go on a variety of amps, of course. And we're starting with a completely bone stock 2203. So the results may not be as dramatic as, some other installations where you're installing it in an amp that's already modified for more gain. But honestly, like in the room playing this thing, it really makes it fun to play. And then when you turn the Add-a-Stage on, you turn it back off, it's kind of like, oh man, I wish it was back on again, because it just adds that saturation and that feel. And it still keeps the core Marshall tone and the openness and the clarity and the bite, which is great. The last clip I recorded with the extra changes to the circuit, the bypass capacitor and lowering the cold clipper. Also really cool. It sounds good. It sounds a little more gainy, but you know, for what it is and for that pure Marshall tone, if that's what you want, I just leave it with the Add-a-Stage only, and it's really, really good. You can't go wrong with that. Other thing I messed with a little bit, I didn't put it on camera yet, is the plate resistor and the Add-a-Stage. So the way it comes is a 150K plate resistor. Stock Marshall will obviously be 100K. A lot of guys use 220K, which is cool. I mean, I tried that. I tried it during the filming of this video, and it adds a good amount of compression. It's a little greasier feel. It's easier to play. But again, it starts going a little too far, and you start taking away that classic grind, that Marshall DNA in the feel. So I chose to go back to the 150K for these demo purposes, and I think that was the happy medium. I tried 120K and 100K, but it's a little, it's not as good a feel, and I think the 150K is a great compromise. It works really well in this situation. So my takeaways from this is I prefer overall the Add-a-Stage inserted between the stages, right in front of V2A. That's my personal preference, but I would encourage anybody, like I said, to try both ways. It's not very difficult to do it both ways. You know, up front has a little more bass, a little woollier. I feel like in the middle is more aggressive and a little tighter. So that's kind of my style. But they're both really good. There's nothing wrong with going either way, and you'll be good. So I think we've covered pretty much everything. This has been pretty detailed. But anything else, any questions, shoot me an email, groundzeroamps@gmail.com, or check the website for additional resources and information with schematics and part information and values and part numbers. They're all on there. Take it easy, guys.